You guys did your simplifying of radicals last night for homework, so hopefully that went well. So the only thing that we need to cover today is all of our operations of complex numbers. So we need to make sure we can multiply, make sure we can add, make sure we can subtract, and make sure we can divide using our complex numbers. Okay, so not too tricky, hopefully. So we'll start out with the easy ones. We've got the square root of -6 times the square root of -5. All right, so what is your first gut instinct to want to do to that problem? Multiply everything together, right? And make it just a positive 30 is your first instinct, right? But we're not going to necessarily do that because it's not correct. Like, I can't just take that and make that become a -30. What I can do is turn them into my imaginary numbers right away. So the square root of -6 is I root 6. And the square root of -5 is I root 5. Yes. Correct. So my I times my I is going to become an I squared. And then the square root of 6 times the square root of 5 will become the square root of 30. Now, what do we remember I squared to be? -1. So we need to remember that I squared is equal to -1. So whenever you see an I squared, that's going to automatically become a -1. Okay, so this really becomes -1 square root of 30, or writing it out without the 1 is probably the more proper technique, just negative square root 30. Okay, so do not just say right away, oh, that's the square root of 30, done, because it's not. It's negative square roots of 30, because you got to punch the I out. Give it a black eye and punch it out, right? Pop the eye out. No? Yes, you guess so? All right. You okay with that one? Next one would be the square root of -8 times the square root of -6. Square root of -8. Well, just the square root of 8 would be what? 2 square roots of 2? Right? Because 4 times 2. Square root of 4 is 2. So this would go, so I'll just write it out. So it'd be 4, 2, so 2 square roots of 2. So 2I root 2 is my square root of -8. Can't simplify the square root of 6. So that's just going to become an I root 6. Okay, so 2I times I would be 2I squared times the square root of 12. So we got a lot more simplifying we can do. What does 2I squared become? -2. Keep in mind that I squared is the same as -1. So that's going to become a -2. What does the square root of 12 simplify to? 2 square roots of 3 times that -2. Sorry, I'm getting low. I'll go top here. So now we have -2 times 2 square roots of 3, which would be -4 square roots of 3. Okay. Questions with multiplying? This is just basic multiplying. We're going to have to do foiling here in a little bit. All right, so let's just do basic dividing. So we have the square root of -80 divided by square root of -5. Before I can do anything, you got to pop the I out. So this really is I root 80 divided by I root 5. Yeah, so the i's will cancel out in this case. And because the square root of 80 and the square root of 5 both have square roots, before I start rationalizing it, 80 does divide by 5. So i's cancel. What is 80 divided by 5? Is it 16? 5 was an 8 once. Yeah, 16. There we go. And the square root of 16 is 4. Good. So my final answer is 4.
We don't even need to remember the i's.
Yeah, because they cancel out from the top and the bottom.
Wow.
Unlike multiplying, where they would multiply to get to I squared. Alright, let's do one more of these. So the square root of 40 divided by the square root of 10. How many i's are you going to have in this problem? Just 1 in the numerator. So that becomes an I square root 40 over the square root of 10. And the only reason why I'm not simplifying right away is because in my mind I see that 40 divided by 10 does divide nicely. If that wasn't the case, then I would just start simplifying my radicals. So 40 divided by 10 is 4. So we get I square root 4, which the square root of 4 is 2i. Good. Okay. So there you do not have your i's canceling out.
So just to kind of get the question, if the I in I square roots of 40 over the square root of 10, if the I was like a 2, would we be able to simplify the radicals? Or
If it was a square root of 2 that you were left with?
if it was 2 square roots of 40 over the square root of 10, would we be able to divide the 40 by 10? Or is this case exclusive to the...
There was a 2 hanging out in front?
Yes.
You could still simplify the radicals.
Okay, thank you.
And then you would just have that 2 out there.
That's right.
Yeah. All right, so we've got basic multiplying, basic dividing. So now let's go to adding and subtracting. So we've got complex numbers, and whenever you have imaginary complex numbers, you always write the real number first and the imaginary number second. So you do real and imaginary, where your imaginary part is always the part that is next to the I. But all you're doing is you're just adding your real with your real and your imaginary with your imaginary. So my real part in the first binomial is a -1. My real part in the second binomial is a 9. So -1 plus 9 combines to make 8. Then you add your imaginary parts together. A -8i plus a -3i would make -11i. There it is. So don't make it any more challenging than that. So just add your real with your imaginary with your imaginary. So here we have 3 binomials. So -3 plus 2i plus 1 minus 3i plus -7 minus 5i. You guys okay?
Yeah.
So when you add all your reals together, we get what? -3 plus 1 is -2 plus -7 gets me -9. 2i plus a -3i would be -1i. Yep, so -6i. And there it is. And you just do the same thing for subtracting. It's just that you subtract instead of add. So if I had -1 plus 2i minus 4 plus I, what's my real part going to get?
-5.
Yep, -5, good catch. And my imaginary would be just an I, good. Okay. So we got basic multiplication, don't forget to pop the i's out. We got basic division, don't forget to pop the i's out. Basic adding and subtracting. So now can we get to distribution and foiling? Okay, so this is the more challenging of the lesson. So here we've got multiplying using distribution. So 6i times 4 plus 3i. So this is where it gets a little bit more complicated because you're going to end up with those I squareds. And we have to remember that I squared is negative 1. So distributing 6i to a 4 gets me 24i. 6i times 3i would be 18i squared. But we have to remember I squared is equal to negative 1. So that means this will be 18 times negative 1, which will be negative 18. Bless you. And try to get in the habit of writing your real part first, imaginary part second. So it'd be negative 18 plus 24i. If you don't write it that way, I'm not going to take off points, but you should try to get in the habit of doing that, because that's the proper way to write a complex number. So negative 18 plus 24i. All right, let's do a FOIL. So 3 plus 2i times 3 plus 4i. So double distribution or FOIL, whatever you want to call it. First times the first gets me 9. 3 times the 4i gets me 12i. Now distribute the 2i everywhere. 2i to the 3i is 6i. Now the last would be 8i squared. So again, 8i squared really will become a negative 8. When I combine that negative 8 with my positive 9, I'm going to end up with 1. And then combine your i's in the middle. So 12i plus 6i would be 18i. Okay. So I squareds. Remember, when you multiply them out and you get I squared, it's going to result in a negative of whatever it is. If it's positive, it'll become a negative. If it was negative, it becomes a positive. All right, we got foiling, distribution. So now we can do division with multiplying by conjugates. Yes, okay. So we'll skip that. So last thing we have to do, and then we'll throw notes on the powers of I again, because you're going to see them again on your homework, is the complex number 6 plus 2i being divided by 4 minus 3i. So we're still multiplying by the conjugates. Any guesses on what you think the conjugate of 4 minus 3i would be? Yeah, we just changed the sign. Good. 4 plus 3i would be your conjugate. You're just changing that sign. So if it's a negative, make it a plus. What you multiply by the bottom, you must also multiply the top by. So now we just have a bunch of foiling to do. The beauty of your denominator is my middle two terms will cancel out, so I don't necessarily need to do that. So 4 times 4 gets me a 16. My 12i minus 12i is going to go away, so I'm not even going to write it. My last gets me a negative 9i squared, which negative 9i squared would turn into a positive 9, just a positive 9, not I squared. So 16 plus 9 means my denominator is going to be 25, which is good because I don't have any more i's in my denominator. Now I've got to multiply the top part, which is a little bit more work. So 6 times 4 gets me 24. 6 times 3i, 18i. 2i times 4, 8i. 2i times 3i would be positive 6i squared, which really would be a minus 6. So 24 minus 6 is what, 18? So I have an 18 in my numerator. 18i plus 8i would make 26i all over 25. Can I simplify my 18, 25, and 26? No, can't divide anything out of all of them, so I would just leave it as such. Okay. Do I need to do another one of those, or do you think you guys got that? You okay? All right, so the last thing that I would put on your notes for those power of i's, like we did on the back of your homework. So powers of I is to kind of maybe put this clock where I to the 0 is equal to 1. I to the 1 is equal to I squared is equal to -1. I to the 3rd is equal to -I. And then the trick that I use, because it's less work, is I divide the exponent by 4, and then look at the remainder. So if it's 0, then you go to the I to the 0 power. Bless you. Bless you. If it's 0.25, then you go back to I to the 1st power, which is I. If it's 0.5, that means your remainder is 2, which would take you to I squared, which is -1. If it's 0.75, then it would take you to I to the 3rd, which is a -I. Okay. All right, and that's it in a nutshell. So, my question to you guys is, do you want to take just all